Hi everyone, this is Module 1, Section 5 on absolute value. And let's talk about the notation first. Sometimes in a math problem, you see something that looks kind of like parentheses, but it's not parentheses. It's two perfectly vertical lines like that. What that means is absolute value. So right there, there's an example. If you see the number 5, and it has those two perfectly vertical lines around it, that means the absolute value of 5. Or it might be not just a number, it might be an expression. So what I typed next is I did 2x minus 7, but I did the same thing. I put those vertical lines around it. Those two vertical lines surrounding something, remember, kind of like parentheses, but not curved, straight lines. That means absolute value. So that's our notation. That's how you recognize absolute value. Let's talk about what it means. What absolute value is, it's a math function that turns numbers positive. Just automatically makes it positive. So what that means is if the number is already positive, just leave it. It doesn't change it. So we go back to my example from earlier. Absolute value of 5. That just equals 5. 5 is already a positive number. If the number is negative, then it makes it positive. So the absolute value of negative 17 equals positive 17. So by itself, when you're just dealing with numbers, absolute value is real easy. If a number is positive, leave it. If a number is negative, make it positive. That simple. The problem is when you start throwing in variables and expressions, it gets a little trickier. So let's say you have something with more than one part. So like instead of just 5, it's x plus 5, or 2x minus 7, or p plus 3, or something like that. You get this expression that has parts to it, but it's still the absolute value. You cannot do each part separately. So I said, if I have the absolute value of x minus 5, you can't say, okay, absolute value just turns everything positive, so I'm going to turn that minus into a plus. That does not work. So the absolute value of x minus 5 does not equal x plus 5. What you need to do is evaluate the number first. Then, when you're completely done with everything between those two absolute value bars, then you make it positive, or leave it positive. That's when you do the absolute value part. So here's our example for today. Let's say we want to evaluate the absolute value of 2b minus 12 if b equals 4. Now see, what you can't do is say, oh, I see that minus 12, it's absolute value, let's make that a plus 12. That would give you the wrong answer. That's not what we're doing. What we want to do is do two completely separate steps. One of them is like we did earlier in the chapter where you go, okay, I'm going to substitute 4 for b. I'm going to do my order of operations, multiply, divide, etc., etc. At the end, when I have my final answer, I'm going to do absolute value. If it's positive, I'll leave it. If it's negative, I'll turn it positive. So let's do that. Let's start by recopying the problem, but instead of b, I'm going to substitute 4. So instead of 2b, I have 2 times 4. We'll leave the minus 12, and the whole thing's an absolute value. So now inside, I'm going to do order of operations. I have 2 times 4 minus 12. The times comes before the minus. So I'm going to do 2 times 4 is 8. And then I do the subtraction. 8 minus 12 is negative 4. So what I got after evaluating is negative 4. Now's when I do the absolute value. Absolute value takes negative numbers and turns them positive. So my final answer to this question is not negative 4, it's 4. And absolute value can get a little bit trickier, but this is as far as we're going for today. For today, we just want to get used to doing the absolute value, doing the substitutions, and then at the end, deciding whether it's positive or negative, and deciding whether we're going to leave it, because it's a positive number, or take a negative number like we did here and turn it positive. And that's, for now, all absolute value does. It's a nice, easy lesson for us.